Let me share something fascinating with you today, something that unfolded just recently over Western Germany and had thousands of people absolutely convinced that World War III had broken out. I'm Professor Douglas Whitfield, and I've spent decades studying near-Earth objects, atmospheric physics, and the long, chaotic history of rocks falling from space onto our little planet. So when something like this happens, I pay attention, and today, so will you. It was an ordinary evening in the western part of Germany, the kind of quiet Tuesday or Wednesday where people are winding down, maybe watching a bit of television or walking the dog, when the sky suddenly did something extraordinary. Residents across not just one, but several federal states simultaneously reported a blinding flash of light cutting across the darkness. We're talking about North Rhine-Westphalia, Rhineland-Palatinate, Saarland, and Hesse, all seeing the same blazing object carving a luminous path overhead. Within minutes, social media was flooded. Hundreds of videos appeared, dashcam footage, doorbell cameras, people pointing their phones skyward and narrating in hushed, panicked voices. A glowing streak moving at tremendous speed, trailing what eyewitnesses described as a long, burning tail. Naturally, the first instinct for many was not meteor, it was missile. And honestly, I understand that completely. When you're living in a country right in the middle of Europe with ongoing conflict in the Middle East, with talk of Iranian strikes on American military installations like Ramstein Air Base in Germany, when an object screams across the sky leaving a trail of fire, your brain doesn't think fascinating astronomical event. Your brain thinks run. Police switchboards lit up. People called in reports of rocket attacks, military operations, unidentified projectiles. A few particularly creative witnesses apparently reported alien invasions. But the authorities moved quickly. Within a very short time, police had contacted military installations, including Spangdahlem Air Base, and received confirmation. No aircraft were involved, no weapons had been launched, no military activity of any kind was underway. Meteorologists were brought in. Tracking data was analyzed, and the conclusion was unanimous. What Western Germany had just witnessed was a large meteorite entering the Earth's atmosphere and breaking apart spectacularly on its way down. Now, before we talk about what happened on the ground, and something quite remarkable did happen on the ground, I want to take you up into space for a few minutes, because to really appreciate what people witnessed that evening, you need to understand the extraordinary journey that object had been on before it lit up the German sky. And trust me, the backstory is just as dramatic as the fireworks. The solar system, ladies and gentlemen, is not the tidy, empty place that planetary diagrams in high school textbooks suggest. Between the orbits of Mars and Jupiter, there exists a region we call the asteroid belt, a sprawling, chaotic collection of rocky and metallic objects ranging from tiny pebbles to bodies hundreds of kilometers across. Most of the material in the belt has been there since the very formation of the solar system, roughly 4.5 billion years ago. These are not second-generation rocks, these are primordial, the leftover raw materials from the construction of the planets themselves. When a piece of that material eventually lands on Earth, scientists aren't just excited, they are ecstatic, because what they're holding is essentially a time capsule from the birth of everything. Now, how does a rock that's been minding its own business in the asteroid belt for 4.5 billion years suddenly decide to visit Germany? Well, it doesn't decide anything, but gravitational forces certainly do. The asteroid belt is not a stable, static environment. The massive gravitational influence of Jupiter constantly perturbs objects in the belt, nudging their orbits. Over millions of years, collisions between asteroids send fragments spinning off in new directions. Some of those fragments drift into what we call resonance zones, regions where the orbital period of the object aligns with Jupiter's in such a way that the planet's gravity delivers a steady, rhythmic push, like pushing a child on a swing. Eventually, that push is enough to move the object into a new orbit entirely, one that crosses the path of the inner planets. Once a fragment crosses into the inner solar system, it becomes what we call a near-Earth object, or NEO. Its new orbit may bring it close to Venus, Mars, or Earth over thousands or millions of years. Most of the time, these objects sail past us at safe distances. But orbital mechanics is a game of probabilities played out over geological timescales. Eventually, statistically, some of them hit. The object that visited Germany almost certainly had a trajectory that had been slowly shifting for millions of years before it had its appointment with the atmosphere. Here's something I find particularly mind-bending. That object, estimated at roughly 1 meter in diameter based on expert analysis following the event, had probably been traveling in relative isolation for a very, very long time. It may not have experienced a significant gravitational interaction or collision in hundreds of millions of years, and then, in the span of a few seconds, it plunged into a planetary atmosphere at tens of thousands of kilometers per hour and was gone. Billions of years of silent travel ended in a light show over the Rhineland. If that doesn't give you a sense of perspective, I'm not sure what will. So let's talk about what actually happens when one of these objects hits the atmosphere, because the physics here are genuinely spectacular, and they explain everything people witnessed that night. When a meteoroid, that's the technical term for the object before it enters the atmosphere, arrives at the upper edge of our atmosphere, it is moving at somewhere between 11 and 72 kilometers per second, depending on its orbit. To give you a point of comparison, a rifle bullet travels at roughly 1 kilometer per second. So we are talking about an object moving somewhere between 10 and 70 times faster than a bullet. At those velocities, the air in front of the object cannot get out of the way fast enough. Instead of flowing around the object, the air gets compressed, and compressed air heats up dramatically. The temperature in front of a fast-moving meteoroid can reach several thousand degrees Celsius. The outer surface of the object begins to ablate. Essentially, it vaporizes. This creates the glowing trail people see. A deep superheated column of plasma and vaporized rock material streaming behind the object like a comet's tail. If the object is large enough and moving at the right angle, it doesn't just quietly fade out. It produces what we call a fireball, or in more spectacular cases, a bolide. A fireball bright enough to cast shadows, sometimes visible in full daylight. These events are accompanied by sonic booms and, occasionally, a low-frequency rumble called an infrasound wave that can be detected hundreds of kilometers away. Eyewitnesses in Germany reported hearing a loud bang or crack, consistent with the sonic shock wave generated as the object decelerated through the lower atmosphere. Now, a 1-meter diameter object of rocky composition will typically not survive the trip through the atmosphere in one piece. The aerodynamic and thermal stresses are simply enormous. What usually happens is that the object fractures, sometimes gradually, sometimes all at once, producing multiple, smaller fragments. Those fragments continue to ablate individually, which is why witnesses often describe seeing multiple glowing streaks branching off from the main body. The videos that appeared on social media from Germany showed exactly this: a primary object with visible fragments breaking away, each trailing its own luminous path. The smaller those fragments are, the more they decelerate in the lower atmosphere. At some point, they lose all their cosmic velocity entirely, a moment meteorite hunters call dark flight, and begin falling like ordinary rocks under gravity alone. Depending on altitude, these dark flight fragments can land many kilometers from where they first became visible, which is exactly why specialists are currently searching a wide area around the Eifel and Hunsrück regions for additional pieces. And now we come to the part of this story that made international headlines: the house in Koblenz. One of the fragments, a piece of genuine space rock, billions of years old, that had just completed a journey from the asteroid belt, came straight down through the roof of a residential home in Koblenz. The impact punched a hole roughly the size of a soccer ball through the roofing material and damaged the bathroom below. I have to pause here and just appreciate how cosmically improbable, yet somehow perfectly comedic that is. Of all the places this ancient traveler could have concluded its journey, the open countryside, a river, a field. It chose someone's bathroom. Police confirmed no injuries resulted from the impact, which is genuinely fortunate given the alternative. Fire services were quickly on the scene and conducted both chemical and radiological assessments of the recovered material. Everything came back clean. No harmful chemicals, no radioactivity. The residents, once the shock wore off, could safely be around the fragment, and the police themselves began systematically searching the surrounding area for additional pieces, not just for safety reasons, but because of the enormous scientific value those fragments represent. You know what's interesting? The authorities had to reassure the public that this was safe to handle, because people's instinct was reasonable caution. But chemically, meteoritic material is just rock. Stone meteorites, the most common type, are largely composed of silicate minerals, essentially very old, very well-traveled gravel. The dangerous thing about a meteorite is not what it's made of, it's the velocity at which it arrives. Let me take a moment to talk about the economics here, because this is actually quite relevant to the story. Meteorites are commercially valuable in ways that might surprise you. The general rule among collectors and dealers puts the price for common chondrite meteorites, the most abundant type, at anywhere from a few dollars to several dollars per gram. Rare types can go far higher, but even ordinary stone meteorites from a well-documented fall can command prices in the range of €5 per gram, meaning a kilogram of documented meteoritic material could be worth roughly €5,000 on the open market. The legal situation in Germany, as in most European countries, follows property law. If a meteorite lands on your land, it belongs to you. The fragment that went through the Koblenz roof is, legally speaking, the property of whoever owns that house. So the homeowner, in addition to having a very unusual home repair project ahead of them, may be sitting on a collectible worth a meaningful sum of money. Science gets the data and the documentation. The homeowner gets the rock, and the rock's journey from the early solar system to a German bathroom is, in a sense, complete. I want to bring some broader perspective to this, because the event in Germany, while dramatic and visually spectacular, is really just a small chapter in an ongoing story that has been playing out for billions of years. Meteorites land on Earth constantly. I know that statement surprises people, but it's true. Estimates suggest that between 36,000 and 78,000 tons of extraterrestrial material arrive on Earth every single year. Now, most of that is dust, microscopic particles that burn up completely in the upper atmosphere or drift down so slowly and quietly that nobody notices. Events involving objects large enough to produce visible fireballs are less frequent, but still number in the tens of thousands globally each year when you count everything detected by instruments. Events producing fragments large enough to reach the ground, actual meteorite falls, are far rarer, perhaps a few dozen globally per year that are ever actually documented. And events in densely populated areas where witnesses and cameras can capture the whole show? Those are genuinely uncommon. Germany got lucky in the sense of having something worth watching, but the history of our planet has also been shaped by far more consequential impacts than a soccer ball-sized hole in a bathroom ceiling. Perhaps the most famous, and certainly the most consequential for the history of life on Earth, is the impact event approximately 66 million years ago that contributed to the extinction of the non-avian dinosaurs. The object responsible for that event is estimated to have been roughly 10 to 15 kilometers in diameter. When it struck the shallow sea that is now Mexico's Yucatan Peninsula, the energy released was incomprehensible, equivalent to billions of nuclear weapons detonating simultaneously. The immediate effects included massive wildfires, a tsunami that scoured coastlines thousands of kilometers away, and a global dust and soot cloud that blocked sunlight for months or years. The resulting collapse of photosynthesis and the food chain it supported drove the extinction of approximately 75% of all species on Earth, including virtually all non-avian dinosaurs that had dominated the planet for over 150 million years. For comparison, consider the Barringer meteorite crater in the American Southwest, a structure roughly 1.2 kilometers across and about 170 meters deep, created by an iron meteorite estimated at perhaps 40 to 50 meters in diameter that struck approximately 50,000 years ago. The energy released by that relatively modest impact was on the order of 10 megatons, comparable to a very large nuclear weapon. The crater it left remains strikingly visible today, a permanent scar on the Arizona desert that tourists visit and geologists study. The object that passed over Germany last week was roughly 1 meter across. Perspective, again, is everything. The question naturally arises, could something truly catastrophic happen again? And the answer, based purely on probability, is yes, eventually. The solar system still contains millions of near-Earth objects, and our ability to catalog them has been improving dramatically in recent decades. There are ongoing international programs devoted entirely to tracking potentially hazardous asteroids, objects large enough to cause regional or global damage if they were to strike. In 2022, NASA's DART mission actually demonstrated the ability to alter the orbit of a small asteroid through kinetic impact, proving in principle that we have at least one tool for planetary defense. The scientific community takes this seriously. Planetary defense is a legitimate field, and while the probability of a civilization threatening impact in any given century is low, the consequences are severe enough to justify significant attention and resources. Back in Germany, the immediate aftermath of the fireball was a rapid transition from panic to curiosity. Once police confirmed there was no military threat, once fire services cleared the meteorite fragments as chemically and radiologically safe, the fear dissolved and was replaced by something more characteristically human: fascination. People wanted to find pieces. Amateur meteorite hunters began converging on the search areas. Social media, which had briefly been a vehicle for alarm, became instead a venue for sharing images of the fragments, speculating about composition, debating the best locations to search. Scientists are particularly excited, and for good reason. Fresh meteorite falls, especially ones where the exact trajectory and source region can be reconstructed from the numerous eyewitness videos and any radar data that may have captured the event, provide extraordinarily valuable material. The longer a meteorite sits on the ground uncollected, the more it becomes contaminated by terrestrial chemistry. Rain, soil bacteria, oxidation, all of these begin altering the original composition. A fragment collected within days of falling can preserve pristine material from the early solar system, including minerals, isotopes, and even organic compounds that formed before the sun ignited. These are not just rocks, they are physical records of the chemistry of the early solar system, and analyzing them teaches us things about the formation of planets, the delivery of water and organic molecules to early Earth, and the raw ingredients from which life eventually assembled itself. The experts working this case are searching primarily in the Eifel region and the Hunsrück, a landscape of wooded hills and river valleys in the western part of the country. Finding dark, fusion-crusted fragments against a background of forest floor and agricultural land is not a trivial challenge, but with the number of vectors provided by the video evidence, scientists can triangulate probable landing zones with reasonable confidence. Whether additional fragments will be found depends on many factors, including how finely the object fragmented, how dense the recovered piece from Koblenz actually is, and simply how many people are out there searching. So let me bring this full circle, because I think there's a larger story here than just one exciting evening in the Rhineland. What happened over Germany was frightening for many people, understandably so given the context of current global tensions. But it was also, when examined clearly, one of the most direct and tangible connections you can have to the deep history of the solar system. A rock formed when the sun was young, orbiting peacefully for billions of years, finally arrived at our planet and announced itself in fire and noise. It punched through a roof in Koblenz, left a hole the size of a soccer ball, and is now sitting somewhere being carefully analyzed by people who can barely contain their excitement. No one was hurt. The only damage was to a bathroom ceiling and to the nerves of several thousand residents who spent about 45 minutes wondering if they were being bombed. I've spent decades studying these events, and I can tell you, the wonder never gets old. Every time a piece of the ancient solar system makes it through the atmosphere and into our hands, we learn something. Sometimes small things, sometimes things that reshape our understanding of planetary formation entirely. The object over Germany was not large by any cosmic standard, but its story, its 4.5 billion-year journey from the first swirling cloud of gas and dust around our young star, through the chaotic early history of the solar system, across millions of years in the asteroid belt, into an Earth-crossing orbit, through the upper atmosphere in a spectacular fireball, and finally through a homeowner's roof in Koblenz, is as complete and astonishing a story as the universe knows how to tell. My name is Professor Douglas Whitfield, and as always, keep looking up.